what else do we need? Let's open up our Jupyter notebook. Where is it? Were you able to do some practice with your lessons, RJ?
Hello, sir. Can you hear me na po?
Yes. Were you able to do some practice?
Medyo na-busy po ako last week eh.
That's okay. So last week we didn't have a class because we had a summer workshop, and I was one of the hosts for that event, and there was no one to substitute for this class. That's why we just canceled it. Let's see. Mm, recursive functions. Actually, right. So I think I didn't edit this one last time. So let's just remove that. All right. So if you remember, we stopped last session with uh scraping a website, just a single page website, like what Wikipedia has. So if you remember, we were using libraries like Beautiful Soup, the one that's already in Jupyter Notebook, the IPython display, the request library, and the Pygal library. So we also learned how to install some libraries, some third-party libraries like Beautiful Soup and Pygal. What else? We get to see how everything that we have learned before in Python, in our crash course in Python, where we are applying everything that we have learned so far, like how to use methods, how to use functions. Um, we also have accessing the lists like this one. We're using string methods like replace and strip. There's also split, right? We also have like um, using charts from Pygel and how easy it is to actually make one. Pygel itself is can work by itself. So we're gonna learn a different library. It's called Seaborn. Uh, for that library, it's dependent on another library. So you need to install that other library in order for it to work. Pygel works by itself. See, so there's only one. For the other one, Seaborn, you need to install matplotlib, which you will learn later. Okay. We also saw how we combine different loops like this one, for loops, and also some conditions like ifs or um, using relational and logical operators. All right. Before we proceed, do you have any questions with everything that we have learned so far?
Wala naman na siya.
Okay. All right. So for now, what we're gonna do is we're gonna proceed to scraping multiple web pages. Okay, because there's no point if we just want to scrape. one page. What if our resources has um, a lot of things that we need to scrape? Like for example, you want to scrape the data of all the movies in that website, all the data they have on their movies. So that would be quite a lot, right? There's thousands of movies already made since what, 80s, 90s. So it's gonna take a while if you're gonna do it one by one. If you're gonna access each page one by one. All right. So in this case, we're gonna learn how to create a program and the logic behind scraping multiple web pages. So it's actually quite simple if you think about it. We already know how to access one page. All we have to do is find a way around that so that you can access multiple web pages. Okay. All right. So here's what we're gonna do. So the wiki page contains links to each of the 100 books as well as their authors. So we're gonna be scraping books and their data. Um, we want our code to navigate a certain list, and then we're gonna extract the name, genre, author, and all the other stuff from that book, and then store it in a variable that we have. Okay. So here are the basic steps that we're gonna do, that we're gonna follow as we're creating a program. All right. First is we're gonna fetch the main URL HTML code, or where all the links are, okay? Because usually when you are viewing a website like Netflix, for example, and then you search for a certain movie, what you get is a page with all the movies that matches what you search, right? So you're gonna have to click one by one on each of those results and then check which one is the one that you want, right? But it's quite a hassle. What if um, you have a program that gets everything and then you have all the data already stored in on your device? So in that way, you can just let Python visit them one by one and collect the data from each of those links. So that's the basic idea. Next is we're going to feed that HTML to Beautiful Soup. We need to read that page with all the links that we need. We're going to extract each book from the list and get the wiki link of each book. See? Next is we're going to obtain the data for each book. So we're going to, we have all the lists, right? So we're going to go through each list. We're going to access each site. And then we're going to do what we did before, the basic scraping of a single web page, and then access another site, scrape a single web page again. So it's that logic, that's what we're trying to do. Last but not least, get all the book's data, clean, and then plot the final results. So that's our basic flow here, creating this program. All right. So first is this is what we're gonna do. Hey, hold on, I'm just rearranging the windows. There's too many windows. Right. I'm gonna send you the link in the chat. So this is the one that we're gonna be using for today. And just for context, this is what it looks like when you visit it. So this is the Modern Library's 100 Best Novels. So if you scroll down here, we have actually a list here. These are just the top 10. All right. Um, Okay, so this is actually a book itself. It's not a list of, it doesn't show all the list. But what we do have is this simple table, all right? And this is enough really for just demonstration purposes, okay? So this is our list. Everything that we need is stored here, right? So we have the year, we have the name, the title, and the author. If you click on Ulysses, right, it will lead you to this page. Okay, so this is the main page for that book. So we're gonna be scraping this page, right? So if we visit another book, The Great Gatsby, it'll take us to another page that has a similar format. Okay, notice the format for Ulysses and the Great Gatsby. So you'll have to take note of that as well. The data for Ulysses is stored in this kind of square, and that's also the same for the Great Gatsby. And inside that square, there are what? The things that we're looking for. We have the author, genre, publisher, date, pages, and the like. So everything, not every book has the same data, right? Like this one has see followed by yeah, this one has no followed by Ulysses. This one has one followed by. So there's a kind of um connecting story, I think. I haven't really read The Great Gatsby, so I don't know. Uh right. So you have to take note of that the data that's presented here, you can't just get all of them because, some books might not have them, others do. So you're going to have to take that into account. Otherwise, your program will create an error and then it will stop running. So you have to be careful. Sorry, let me just. Okay. So the same thing goes for the other books, right? Now just imagine that we have to access each book, okay, 100 times. So that's quite hassle already. But if we have a web scraper, right, it'll be quite easy for us. Okay. So I hope you understand the goal. Um, right. So this will be our main focus for now. So just like before, we're gonna treat this one as a single page. We're gonna access it like it was a single page. So if you're gonna press F12, you're gonna look for this table um, using this element selector. Let's see. So table head, where's the table? All right, so this is the main table. Okay, so just like before, we're gonna do the same thing. All right, so from what I can see, there are no other tables here. So I think it's safe to say that we can just access it directly, like looking for the single table, right? So we can actually, all right. So if we go back here, okay. So first we're gonna fetch the main URL HTML code. So we'll just put this one maybe here. Okay. Um, we're gonna have to import the things that we need first. So it's from IPython display. I think we can just copy this one at the top. So we need IPython, we need PS4, we need request. Yeah, let's just put Pygol there as well. This will save us time. What else do we need? Um, we'll just put the others as we need them. Okay, for now, we're gonna put this one. URL is equals to the link that I gave you. Okay, so URL is equals to, all right. And then what are we gonna do? We're gonna request the page and then get the text. So this will give us the what? This will give us the HTML. So you say page is equals to RQ get URL dot txt. After that, we're gonna pass the entire thing to soup, just like before. Again, you can name it whatever you want, but this is what I did with ours. So beautiful soup is named BS. It has the alias of BS, and then we're gonna pass in the page here. After that, um, soup is now a beautiful soup object. That means we can use all the methods that we have written so far to navigate the HTML page, right? So we're gonna say, let's see, if we go back here, so this is the first row, TR1. This is the second row, so I think we can start with 01. Okay, so we're gonna say rows is equals to soup dot find and then table, right? We can just go directly search for table because we know that there's only one. There weren't any tables earlier. But we can see that later on when we uh, run the code. Okay. Next is we're gonna find all the tags that are ER. Okay. And then we also know that we're gonna have to start at one up until to the end. So just like this. Okay. And if we print the rows now, all right, let's see. 1992 Ulysses. All right. Identify Great Gatsby. Okay. So we got the correct data. Um, just to make sure the last one is the grapes of wrath. The grapes of wrath. Yes. So we got the entire row, and in that row is all the data that we need. Okay. More specifically, the link. Okay. So what do we do? After getting the rows, all right, we need to access um, each row and then create an array of links. Okay, we'll just save it to a list. So we're gonna use list comprehension here. So we're gonna say book list or book links, and then we're gonna say row dot find. No, no, wait. For row in rows, right? What will it do? Um, what will it do for each row? It will row dot find. What will it find? Um, so for example, this one, this entire row here. Okay, so we have TR. Again, what we're looking for is a link. So where do links usually are usually stored? Can you tell me, RJ?
Hello, sir. Sorry.
Yes. Where are links usually stored? What HTML tag is used to store the link?
I think if I remember correctly, it's in the body part.
Yes, it's correct. It's in the body part. Actually, it can be
Uh,
anywhere, but the specific tag, the
isn't
specific,
it the href?
Yes, that's correct. So href is the attribute. A is the tag, so it's called the anchor tag, right? So good work. You still remember where to look for it. Okay.
Yeah.
So if you've noticed, right, href here, it's not really a complete link. Okay, you see wiki slash Ulysses. So it's not really a complete link. Um, so more like this is the thing that you add to the um, base URL. All right, so we have a base URL. You're gonna have to add this one. See? So whenever, for example, this one, okay, take a look. So it says Wiki Ulysses novel, right? And this is what we have here, Wiki Ulysses novel. The same thing for the Great Gatsby, okay? The Great Gatsby, okay? So this one here is the main URL of the website. And then the things that follow are the different resources that they have, okay? The specific address to that resource, okay? But it's still in the same website. So basically what you need is two. You need the base URL and also the link for the resource, the specific, text for that resource needed, the link. So that's what we're gonna do. Okay, we're gonna collect all the A tags and then get all the hrefs. So this is what we're gonna do here. We're gonna look for all the A tags, this one, and then for each A tag, we're gonna get the href attribute. All right. So with that, we now have a list. Print book links. All right, see? Now we have a list of all the links that we need. Okay. After that, let's see, we also need a base URL, right? Base URL. So that would be what? HTTPS, this one, wikipedia.org. Okay. So this is a string. And then we can prepare it in a way that the link is ready. Okay. So what do we need to do? We need to combine the base URL to each of the link that we have here. So um, we'll have to make a new list. So books URL, right? Um, we're gonna loop again for links in books links, right? We're looping to each one. And then what are we gonna do for each link? We're gonna add base URL directly to each links because they are text. They'll just be concatenated, right? And if you take a look at this one now, if you print this books URL, hmm, books links is not defined. Books, you have to be careful with the spelling. All right, now each one of them is a link, okay, and each one of them is even clickable. See, so now this is ready, and the links are ready for us to go directly to that website, to that page. So if I go here, if I click on it, it will lead me. mm, it's not running. Or okay, so there's double slash. You need to remove that one slash. All right. Ulysses novel. Uh, I did it twice. Okay. Just the guess. Hmm. All right. What? The Great Gatsby is loading, but for Ulysses, it's not. Why is it only hmm, Ulysses? It's not loading properly. I wonder why. href. For some reason, it's not connecting to the proper one. Why? So it's lacking the open, the closing parentheses or the link in order for it to work. Oh, so for in these kinds of cases, you're gonna have to be careful because it's not accessing the correct page that we want. So at times like this, you can put something in your program that says if there are a lot of data that's not on the page, then you can disregard the entire data itself so that the other data that you collected that were correct won't be affected, right? So how do we fix this one? We're just looking for the basic links. Anyway, let's just try this one later on because we're just directly clicking on the link in the list. Hopefully the request later on can access this one correctly. Okay. All right. Any questions so far up until this point?
Wala naman na sir.
So next is we're gonna obtain the data for each book. So we're gonna access each book, we're gonna get the data, and so on and so forth. So we have this link here. You can click on this link to review the code, but we can just, yeah, we can just copy and paste the functions. Anyway, these functions are ready-made, but we're just gonna review them still, okay? Basically, these functions are for getting each data from the page, the book. Let's visit another book again. All right. So what are the different data that we need again? We need the author, the genre, publisher, We need, what else do we need? So author, book name, the genre, publishing date, page count. So these are the things that we need. Okay, now we're gonna analyze this simple thing here. We're gonna analyze it. So, okay, we're gonna look for author, or maybe in the name for now. All right. So it's kind of unique, this box, if you see. No other boxes exist in this page, and it's similar to other books. So we can say that all the data we need is in this box. But it just so happens that this box here is actually a table. So this entire thing here is actually a table. It doesn't look like it at first, but it's actually a table as you can see here. So basically we could just look for the table again, or if you want, you can use the class. Okay, it has these properties. Oh no, these classes. Info box, IB book, and then record. So we can use that if you want. Okay. So let's see. Find book name and table. So we're assuming that the table here is this table, right? So this function is expecting that we're gonna pass a table to this function. Okay, so odds are it's this table, all right? And then it's gonna look for what? The caption. Maybe because there are no other captions here. Usually the caption tag is almost always at the top at the beginning, usually for the name of the file or the subject. So you can be confident that there's only one. Um, so that's why it's looking directly for the caption and then assign it to the name variable, and then it will return the text, or in other words, the main title itself. So it's gonna do the same thing for the author. All right. Now for the author, if you go to the author, the line here, all right. What can we do with the author? Mm. All right. So what we can do is we can look for the specific string called author, right? Because there's no other author here. So we can just look directly for the string author. It will give us this element. Okay. Then after that, we can do a next. So remember the relationship between different tags in HTML. So you have the parents, the child, the siblings. Remember that one? So for siblings, what do? We use the next method, right? So the next method will just go directly to the next element that it has by its side. So in this case, it's TD, okay? And that's what we actually have here. So table.find author, and then we're going to use dot next, right? And then dot text. Okay, so dot next is actually a what? It was the method was property. So you're telling Python to look for the element with the text author and then go to the next one after that, that's a sibling to this one, and then access the text. In other words, from here, go to the next one and then get all the text inside of this HTML element. All right. And what you will get is, of course, the name of the author. So this is how this function works, right? Next is we have the table. So, oh no, wait, the genre of the table. We're looking for the genre. So just like the same concept with author, you're just looking for the text itself. if you find the text, what does it say here? Genre. So yeah, it has the same format, TH, and then what follows after that is the TD. And then you can just get the text for the entire thing. And all the elements inside of that, their inner text, the one in between the opening and closing tag, is gonna be retrieved. So it's modernist and novel. So modernist novel, right? So this is what you have here for the genre. So you might be asking, what's for the other one, the else? So it's looking for something called subject and then next, 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 and then text. So it's much further away, right? You can just imagine right now that it's three um, elements away further. So it just so happens that in other books, all right, in other books, if you were to actually look for each one, there will come a point where instead of genre, it will say subject. So you need to consider that one. What if the genre is not there? What if it's the word subject? So you need to consider that in your program. And that's what it did here. And it also knows that whenever the genre is named subject, its characteristic is that it always appear uh, after the next three HTML elements, and then you get the text to get the entire text, right? For the publication date, it's basically the same thing. So you find and then text publication date. Next the text. You go back here, publication date, next the text, right? Um, so what is it doing different here? So publication dates are what dates and how are dates stored in this website? It's stored in this manner, February 2, 1922. So if you go back here and take a look at our pattern and year, right? So we are looking for a digit with four numbers in succeeding order. So this is what? This is a uh forgot the name. It's called a regular expression. There you go. So when you're looking for something, you have some kind of syntax that you have to follow specifically if you want to search for uh something. So D here means that it's a digit. So 0 to 9. 4 here means that there are four numbers. And then a slash here at the beginning indicates that it is there. Okay. So after locating the date, so in here it's trying to look for this one, the date 1922, right? And then after getting the date, okay, you can go back and give the data that you had, which is the year, of course, right? And then we're gonna have to need the regular expression, regular expression for this function to work. So uh, we're gonna have to add it here at the top. So we're gonna say import RE. All right. So import RE, and then Yeah, I think that's it for now. So, and finally, the last part, it's the pages count. So it's as easy as the book name earlier. Just look for the word pages for that element and then go to the next one and then look for the text data and then return how many pages there are. Okay, so it needs to use the int function because this is in text. The number is in text format. It's not in number format yet. Okay. So do you understand that the purpose of these functions? These functions are by itself not going to work. Okay. You're going to have to use the function and then pass the correct data table. Do you understand?
Yes, sir.
All right. Any questions so far?
None so far, sir.
Next. Let's see. We're done with that. We're done with that. We're done with that. And this is the next one. Okay, now we have these cool functions. Let's write the function to use these functions. This will help us with the automation. Now, if you just visit this site, it will give you the link to the code, and then we'll just copy it. Okay, so that it won't take us too long to type it out. Okay, anyway, we're gonna discuss this one as well. Right. So let's just put some separation there. So we named this one Get Book Info Robust, right? What does it need? It needs the URL of the book. So this is what we're gonna do. Okay. Now, we have a note here to avoid breaking the code. You should use a try and where's the try except? Okay, yeah, try except. So first, you're gonna try these codes are out first. If there is an error, it will go directly to this one kind of parse table, and then it will return back to whoever is calling it. All right. So in this case, return it's gonna return to the very beginning. Okay. Um, what else? So we're gonna try this one, and if we find parse wiki page book, hmm, right. So parse wiki page. Let's look for this one later. What we have here is book.soup.find and then the table with the class of infobox and vcard, right? And of course, an except condition if it can't find it. So next is we're going to create a simple dictionary, this one book info, and then the values for this book info are author, book name, genre, publication, year, page, and count. All right. And these are the functions that we have. So we have get author, find book gem, get name, get publisher date, and then get page content. So each one, right, in their respective index has their respective function for them as well. Okay. So yeah, that's that. Next is we're gonna use the zip function uh in our Jupyter notebook. And what we're gonna do with that is that the zip here will just give out the things in chunks, right? In chunks. And then it's gonna save it to val and func. So it's gonna try val is equal to book table. Otherwise, it will say none. All right. So what's the main point here? What is the main point? Hmm. The main point here is that once the table is ready, right, and we have the values that we need, the keys, and also the functions, right? Um, what this will look like is a dictionary of functions. So if you were to print this one when this is running, let's see. I wonder if we can view it without an access. Mm, right. So I don't think we can see it, but we're just gonna have to write it out. So again, um, we have book info, right? It's a dictionary. And we have val here, which is author, book name, genre. So what's gonna happen with this for loop is actually pretty simple. What will happen is something like this. So book underscore info, and then we have the first name of the info that we're looking for. So you're gonna have to like put that here. So author, like that one. And then the value that it has, right, is the function. So it's kind of confusing because we're calling this one values, right? Um, so the actual data for this one. Okay, how do we get it? We are using the function and then bookable function. So function here is what? The functions above on this list. So it's gonna go over each one, each pair, and then run the specific function. So if you've noticed, the name of these functions are the same name with what we have here at the top, right? So we have, where is it? We have find book name and then get author C. So these are actually uh, functions already, all right? So if they are functions already, you can use them directly. You can use them directly or open it up. So in this case, book info author, and then get author is executed, right? The function get author is executed. What should appear here is, so instead of author, let's take the first one. So it's Ulysses, right? And then James Joyce. So we're gonna say James Joyce. James Joyce. All right. And then the value that comes after that is what will result to the function called find book name. Wait, author. Find get author, this one. So it will return the author name. So what we'll see here is actually this one from the author, this text. This is what we should see. So it's gonna display here at this point. Uh the second call that we have here. Right? Um yeah, James choice. Okay, and if you were to loop over all the data that you have, then you also have um, a dictionary somewhere in your program that says James Joyce, and then, oh no, wait, James Joyce is the author. Um, let's see. So this will be the second entry. Right, and so on and so forth. Okay, so it's gonna go over. This is what the zip method will do. It will combine the this list with this other list and then pass them together at the same time to val and font. Over at this point, creating a new dictionary. So that's what we did here, right? Let's see what else. Mm. All right, I think that's it. So you can already see that we've had the data for that book. Okay, not all but some because we're doing it manually. So it was able to access Ulysses and get the data from the three card here, right? So that's what we did. Um, what next? This is the last part. Get all books data, clean and plot final results. So let's just open the all right. So it's gonna use import time. Let's see later on what import time is. So give me a moment. Mm, I think I closed the wrong one. Where were we again? This one, right? Hmm. So import time, we're gonna have to add that one here. At the very top, import time, and then just copy the code below. Right. So I'm gonna remove this one. Okay, now we have a book info list here. So basically, all the information will be listed here. Next is we're gonna loop the first books, right? Again, the break info, or the block info here, book info. When this function is done and then the book info is returned, it will only return the data for that one book, right? Not all the books that we have searched. Okay, just to be sure. So book info list. This is where our final data would be. So it's gonna loop over links in books URL, right? Because it's there, our links to each of those books. We're gonna have to loop over each one, and then we're gonna have to open it. So it says here book info is equals to get book info robust and then link. So it's using this function now, and then we're passing the URL itself. So here, where's the base URL? Okay, it's just copying and then passing the link directly. Okay, so that's what you get here. And then you have an if condition at this point. So if book info really exists, then you're gonna have to append the book info to book info list. Hmm, sleep. So the sleep one here is for, if I remember correctly, is for the security purposes and Wikipedia. So they don't actually allow you to have access to it uh very quickly, right? So they put a limit, right, of waiting for at least a second before doing your next transaction. So as long as you follow their guidelines, rules, uh, you won't have any problem, right? So yeah, you're gonna have to use it responsibly. Next is book info. So each time that the book info is returned, then book info list, the book will be added there. So uh, the book is basically a dictionary, right? After that, let's see. So we have one more here. Data collected. This will take 100 seconds to finish, so feel free to do. And that's actually true. It's quite long already, and there are a lot of functions that it needs to do in order to get the data that we need. So it's gonna take around maybe 5 minutes. So we're gonna have to print out in the end here book info list just to see that it works, right? And then we're gonna have to link, find all. Okay, is it main books URLs is not defined. 77. Where is my line number? 77 books URLs. What did I name mine? Books underscore UR. Name books URLs not defined. Books URL. Books URLs. Or link in books URLs. What is the matter here? Just remove the comments. It's kind of annoying to see the entire code. For link and books URLs, book info, get book info, bust. Books URL. Books URL. There you go. Cannot parse table. Wow. Or why? Let's see. So at least we know that it's trying to access each book, right? URL. We're just passing it here. Book info. Info. That's all right because they are different in their different locations. If book info list dot append book info, I am sleep. Anyway, we'll see this one next, I think, because let's see, different genres. Okay, hold on. I'm just trying to make sure that it's correct. All right. And then the genres. So let's try and copy this. Okay. So we're gonna collect different genres. So where do we get the genre? So we're gonna have to get the book first. So we're gonna have a loop here to access each book data. And then we're gonna have to look for the genre key. After getting the key, um, if it exists, right? What will it do is it will look if the fiction is in the book gen or the word fiction with a capital F. Okay. Um, Otherwise, what would happen is there's no else statement here, so that won't happen. But book gen will now be equal to the word fiction, right? So if either this one or this one comes up, this will be the result. So it might be that in other pages here in the website, there are subjects written in this way or written in this way. So it's not entirely uh, their fault. Next is if book gen not in genres, then count books in each genre. So you're gonna create a new key pair. That's why we say genre books gen, and then equal to one. Otherwise, if it exists before in your dictionary, all you have to do is add one to the current value. So this is actually pretty simple at this part. Next, you can print the genres as well if you want, but it's much better if we go directly to uh, the Pygel here. Did I add the RE? Yes, I added the RE earlier. So we say bar chart is equal to Pygel bar height of 400. We're gonna use the items method for our genres dictionary. So we get the key and value directly, and then if you remember, that's the key and the value, yeah. And then you're gonna pass in those key and values here to the bar chart. You're gonna add the data to the bar chart. That's why it says bar chart dot add. It needs the key and it also needs the uh value itself. All right. And after that, it's just basically us displaying it here. We're just displaying the page, say format, digital bit of that format, and then the bar chart is rendered. So it's kind of different than what we did here before, right? Bar chart that rendered, that's the only thing that we need to do. But the one who made this one, uh, tried to format it this way. So render chart, so bar chart dot render, see? We could have just basically just skip that part and go directly to bar chart.render, and then Unicode is equals to true as well. Now, for some reason, I think that we're missing something, but let me just try and run the code. Okay. All right. So we still can't parse the table. We need to know what's wrong. Mm, base HTML is not defined. Yep. So we can just do the same thing that we did here. HTML bar chart dot vector. Okay. But even though that's correct, we still don't know why it doesn't load. So why doesn't it load? Um, Incomplete input. One, two, three. One, two, three. Okay. So what part are we looking for the data? Okay, hold on. Did you copy the code on your end, by the way? RJ? Hello, RJ? Are you there? Ah, okay. No worries. All right. So if you've copied it, let's try and see if it works on your end because right now it doesn't work on mine. It cannot parse the table, cannot parse table. So why? Okay, let's troubleshoot this one together. That's okay. All right, no worries. But since you don't have your anaconda on your end, just look at my screen. So try to see if you can spot something that I forgot to write. Mhm. So it always says cannot parse this one. So whenever it's trying to access the link, it's gonna return this one instead. Why? Because Parse wiki page book URL. This is wrong. Why are we using parse wiki page? We're trying to access the page. So this should be rq.get, and then this should be .text because we're trying to get the HTML for that book, right? Yeah, I think this is it. Okay, so that's very important what we did there. We're trying to analyze the problem, and that's what makes error messages good because you can just trace it back directly to where it was. And it's still the same. Okay, why? So we are saying rq.get book URL dot text. Okay. What's happening here afterwards? Book soup. Ooh. So if I remember, we have to pass this one first into beautiful soup in order for it to become a object, beautiful soup object. So wrap this one around BS, and then it's looking for table, and then the attributes. That's not, you can't go directly with class. You're gonna have to say, um, what's it again? Attribute ATTRS is equals to this one class colon. This is how you look for attributes isn't defined. So just take note of these errors that we see here. So remember earlier we were just copying the code directly from those GitHub links, right? We were clicking one and then just copying it directly. So to those of you who are viewing the recording, just take note that we are editing this part of our code because it's not going to work if you just copy it directly. So if we run this code again, please work. All right. So as you can see right now, it's turning black, right? That means it's still running. Okay, we can see uh the elapsed time. So we know that it's running. Let's just give it some time. And it's done. But why is it only one? What's happening? Huh. Why is it only reading one? Hmm, let's see. So get info robust append. Okay. All right. Uh, at this point, I want to see what book info list looks like. Because I don't know what it looks like. Alright. So it's not reading anything. Why? Author none, book none. All right. So what's happening? We have get author here. Get author, find book name. We have get genre, find book name. We have get genre. We have get publishing date. We have get pages count. Where's it? Get pages count. All right. And let's see. For val, bulk, and the values functions, try function of book table. It's book table again. Book table. This one. Um, table is a class info box required. Hmm. So it's gonna say none because the only time that it says none because it's gonna try it out. Function table. Hmm. Yeah, because we're gonna pass in the table that's needed. That's why we say book table because this is the table that we got. So we know that this is working already. Find. Right. I think I remember. So it's using the wrong parameter name. So if you go to like BS or beautiful soup, uh, right. So if you were to like look for any string, String. Find all, recompile, stress, sisters. All right, I think I got it. So if you're looking for strings, you shouldn't use text. You should use string, the parameter name string. So all we have to do is swap out everything that says text into string. A very simple error. Pages. What else? What else? What else? I think that's all, right? Text. Text. Next. I think that's all. All right. So I think this is it. And so says none. String find all string is equals to LC string. Find string is equals to Lassie. So we know that this is correct. String, string, find all is actually an underscore. Find all. Okay, so it's still reading none. Let's try and see if we can actually get the book table. Just want to make sure that we're looking at the correct thing. None. So even at this point, it can't see anything. Um, all right. So book table does not exist. What about book soup? So, okay. So we know that book soup works. It's getting the correct HTML and text. However, if we are looking for it, hmm, that's soup by table attributes class colon info box record accept turn on info. But it's not finding anything. Why? Info box table box record info box IB book record table. Let's try adding that. Table. All right. So what we needed was the exact class. So since we were missing the IB book, it did not recognize the table. So I think it's working now because we can see the table, right? If we just scroll down, maybe we can see, yes, we can see now the graph. Um, where is it? Okay, we can remove this one and then run the code again. Use a string instead for the genre. So now we see the error. Earlier it didn't come up because um this was the part where there was an error. We were missing one class in order to accurately find the correct table. All right. Why do I have another print here? Where's this? Print author. Ah, this one. All right. Remove this one. Okay, still running. All right. So let's see. Uh, it doesn't really match what we have here on our PowerPoint, right? Because this is looking at a different web page. I think this is looking at the entire like 100 novels or books that you should read. In our example here, we're just looking at 10 books. So that's why we see a different graph. But this is already correct. Um, Yeah, so one book, two books, two books. Yeah. So all overall, one, two, three, four, five, six, eight, and 10. That's correct. This is 10 books overall. Exactly the data that we have as well. So let's see. Can we expand this one? Maybe I can make it bigger. Nope, it doesn't get bigger. So, all right. So just remember when you're copying the code from the PowerPoint, make sure to change all the attributes, the parameters that says text into string. So at these functions, and then here you need to use rq.get, pass the book soup to beautiful soup, and then look for, you need to add the additional class IB book in order for it to correctly identify this one. So I guess we were kind of confused because we were just copying the code directly from the PowerPoint. So there were some things that were updated, I think. So I think before it didn't really had this one, the IB book, but maybe Wikipedia had an update and they added that class there. So it didn't work anymore. So you're gonna have to be careful whenever you're copying codes. So you have to do your um, research as well. Okay. All right. Any questions so far, RJ? Were you able to follow the corrections that I made?
Yes, sir. Yes, sir.
Right. Any questions?
Wala naman na po, sir.
Right. So with that, I think we're done. Yeah. So that's the conclusion. There's another link for the full code. Yeah, here's the full code. So you also have that one. But again, be careful whenever you're copying code. You might be copying code that's old and has a lot of parameters that don't exist anymore. So you're gonna have to use your brain a little bit to kind of analyze the problem. Okay. What else? So aside from that, let's see. Um, Warnings, yeah. So whenever you're scraping websites, you're basically getting information directly, right? Just be sure that the data that you are scraping is a publicly accessible data. So that means that these websites do not really prohibit any scraping. And then um, an example of this would be government websites. Usually those are free data that you can get as long as you don't need a login, for example. Um, what else? There are some open data repositories out there. There are also some APIs. Um, Usually, you will find this text. So if you were to go to like Wikipedia. So this applies to any kind of website, really. So if you go to the main page of Wikipedia, for example, just org, okay? So this is for all websites. If you type this one directly, let's say, yeah, if you say slash robots dot text, I think, yeah, okay. So You can access this one directly in the root. So when you say root, that's just the base address, base URL, and then follow it immediately with robots.txt, and you will get something like this. So these are basically rules that you have to follow when accessing the website. It's called robots.txt because these are for those programs that are automated, like our web scraper. So they actually have a rule that um, you should not access the page more than once in under 1 second. So that's why we had this code here that says time.sleep is equals to 1. We're gonna have to wait 1 second before it will access Wikipedia again. All right. So you can explore this one if you want. There are some addresses that they don't allow you access to. You'll know that here. The agents that it mentioned here are the different browsers or libraries that you're using, okay, to access the website, those kinds of things. What else? Okay, it's acceptable if you bought. Low speed bots are welcome. Viewing article pages, but not dynamically generated pages, please. So that's an entirely different thing. What we have been viewing right now, in Wikipedia are static web pages. So the two examples that we did for scraping a single page website and a multiple page website, they are not dynamically generated. So when you say dynamically generated, the uh the HTML and the CSS are kind of like created on the go. So it's not really set by default. Um, Examples of these are those shopping sites that you visit, like Amazon or Facebook. So those are dynamically generated. So have you ever noticed that you're never leaving the page? You're just in the same page. It just changes the surroundings. Like instead of the bar is appearing here, it will appear somewhere else because something has changed. So that's uh, dynamic pages. So that's what dynamic pages are. Okay. So for these ones, these addresses you're not allowed to access. Um, does it mean that it has that good of a security? Not exactly. But once they do detect you that you're accessing pages that they don't allow, um, they're gonna ban your address, so you can't access it anymore. And the worst case is they will, you know, trace you and file a lawsuit. So that's one thing that you should avoid. Okay. So just be responsible, just like with any other technology. Um, let's just be responsible in getting the data that we need. Make sure that it's publicly accessible. And then what else? Can we actually search here? Scraping. Wait, I was not really hearing. Uh, if you try out other websites, like for example, Yahoo Finance, Finance, Stock Market, and then you access robots.txt here. Robots.txt. All right. So these are the pages that it doesn't allow. These are the browsers that it doesn't allow. Chat with user, Claude bot, Facebook bot, GPT bot. Um, so there's a lot of things that it doesn't allow. Other than that, it doesn't really say that you can't use web scraping on this website. So that means if you ever want to create like a web scraper for getting the latest data in the Yahoo Finance, then it's perfectly fine. Okay. So I think this is an example of a dynamic website. Let's see. Right. This should change in a few seconds, if I'm right. Let's go to something most active. Yeah. NVIDIA is currently at 154. Right. Let's just observe this one for a few minutes, or maybe 1 minute. It should change. Um, just to show that this is a dynamic website. I wonder if we can make it load faster. 54. Hmm, let's try and look for something else. Something that's always changing. Uh, all right, maybe we'll just have to look for something else. Right. Okay, so if you say settings, for example. All right, so it's not changing. I don't know why, but this website, from the looks of it, it's a dynamic web page. So there's only one page. You're only looking at one page, and then the data is just supplied by the server. And then some parts will just update automatically when they get the data from the server. So kind of like this one. So whenever the price changes for NVIDIA, it will update here. You can't really do that with static pages because from the name itself, it's static. It's already set. Dynamic is the data always changes whenever there's an update. Um, Actually, let's look for more dynamic pages. Dynamic pages examples, just to show you, because it requires a different library to access those kinds of pages. Hmm. What's this? I think this is a game. Hmm. 6. Let's just go to Amazon, maybe. Yeah. Amazon. Okay. So say that we're searching for something like, I don't know, mugs, for example. Okay. So you saw what happened. The moment that I searched, it didn't actually load a different page. We were just staying in the same page. What changed was this part of the page, right? It changed to something like this for the search options. So if you go back to Amazon again, see? It didn't look like it was actually changing, loading a different page. It was still the same page, only the content was changed to make it look like we're at the home page. So that's what the dynamic page is. And for this kind of websites, you're gonna need a different library altogether. But it doesn't mean that you can't anymore scrape websites. It just means that you'll have to do the extra work and study more because this is slightly more advanced than static based websites, right? So that's it for web scraping. I hope you enjoyed this lesson. So how was it, RJ? Do you think you can do this on your own?
With more practice po siguro, sir.
All right. So yeah, that's okay. It's always difficult at first. Right. It's already 3. Let's have a quick break, 15-minute break, and then I'll see you back here. Okay?
Okay po,
We'll
sir.
continue with pandas. Yeah, pandas. All right. So enjoy your break. See you in 15.
Thank you, sir.
right? RJ, are you here?
Yes, sir.
Right. So we'll try and cover what we can with the remaining time that we have for pandas. At most, I think we can finish half of this PowerPoint. But yeah, um, this will be my last session with you guys. So by next week, it will be a different instructor. It will be Ma'am Shaya. So she'll be the one that will continue the lesson with you. All right. Okay. Um, so right. Python for data analysis. So you might be thinking, data analysis and data science are like they're different at the same time they also cooperate with each other. Um, but if you try to differentiate them with their focus, so for data analysis, basically you are analyzing the data to extract insight and inform decision making or inform the decision makers the data that you have, what it means, what it could mean, and then from there, using the data that you presented, they can include that in their thought process on the decisions, the next decisions that they will make. Like, for example, it's related to a product. Did it had a good performance when they tested it out? How many good surveys did we have? In what areas did we test it out? What was the demographic? Was it mostly old people, young people? Who were the buyers? How much was the price? Those kinds of questions, right? Data science is primarily on extracting insights using like machine learning and statistical modeling. So basically, it uses those tools to kind of make a prediction. So it's not really a reliable thing, but you can somehow gauge that if the conditions are right, this will be the result in the future. So you can kind of help guide it along the way to make sure that it gets to that point. So maybe there will be some adjustments in the production, in the um, way that the product is presented or advertised, so those kinds of things. So that's basically it. So we have here um, the basic view of this PowerPoint. So first is the overview of the Python libraries for data science. Next is how to read data. So selecting, filtering, data manipulation, sorting, grouping, and rearranging. So mostly when we get the data, they are not in the shape that we want them to be in. You have to filter it out. So what we get is usually just the raw data. So you have to remove the columns, the rows that you don't need. Like there are, if you can say that if this column has no value for that specific entry, then you can just cancel the whole row itself because it's going to be invalid. Let's say, for example, the age. If the age was not written out during the survey, you can you can deduce that this data is not relevant anymore, even though there is data on the other parts. If it's missing that one important part for your research, then you can decide that it's not anymore useful. So you're gonna have to like sort out your entire um, data set and then remove the unnecessary stuff, remove the things that you don't need, and then rearrange it in a way that is a lot more easier to analyze and read, really, because you're going to be feeding that one later on to our um machine learning library. So it's just like with Beautiful Soup, right? We are passing data, HTML data, directly to Beautiful Soup in order for it to understand. So in this way, it kind of works the same way, but instead of Python reading the HTML, what it will do is it can make predictions for us. So that's what it will do. We'll also be learning how to plot data, but specifically we'll be using Seaborn and Matplotlib at this point. Um, Descriptive statistics. So if you search this one, it's going to say that this will involve numerical and graphical methods. So kind of like um, overview of characteristics, if there are patterns in your data, if there are trends in your data. So this is what descriptive statistics means. So if you ever heard of the mean, the median, the mode, the range, those kinds of stuff, that's what descriptive statistics is. Okay. Next is inferential statistics. So inferential statistics is just um, drawing conclusions, um, making predictions. It can also make predictions by sampling a data set from a specific population. So let's say you have a data set of 1,000, then you'll just get a part of that, and then from that part, you'll make a prediction. So yeah, each one of those things, descriptive statistics and inferential statistics is an entire subject. If you were to put this one in school, so um, they kind of have their own thing. So you're gonna have to learn that one as well. But the point here is that the the functions that are needed, okay, is already in the library that we're gonna be using. So all you have to do is just all it needs is the data, and then it will take care of everything else for you. So yeah, if you were to do this one manually by hand, um, it would take an awful lot of time, and then it would be very prone to error. So as we all know, computers are very good at following orders, and if it's in terms of repetitions, it will always do exactly the same thing as long as the instructions are correct. Unlike humans, we get tired, we get out of focus. There's a high chance that we made a mistake, those kinds of things. So, especially if the project is big, then there needs to be some kind of check or counter check to be done in order to proceed with a certain project, right? Okay. Uh, so these are the Python libraries for data science. So we have these are the popular ones, at least. So we have um, NumPy, we have SciPy, we have Pandas, we have Scikit-learn. We also have Matplotlib and Seaborn. So that is our visualization library. So it makes graphs, basically. And then the one at the top are just for machine learning and modifying our data. All right. So all of these things can be found in our Anaconda Navigator as well. All right. Now, we're gonna have to go over them one by one first before actually trying them out later on. So we have NumPy here. NumPy stands for Numerical Python, and it's a very powerful library. It's very popular, a lot of users, and a lot of other. libraries are dependent on it. So they made their libraries on top of NumPy. So using NumPy as kind of like the base for their library in order for it to work. So yeah, NumPy is not just for data science. It has a lot of applications. So it has like fields like physics. There's also engineering. You can find NumPy for finance as well if you want. So it's not really limited to just data science. Maybe that's why it makes it so popular. Key features. So NumPy has arrays. Um, if you compare it to list to Python, it's actually much more efficient. They have more mathematical operations. So what else? Of course, they have linear algebra. So if you have some complicated equations, it can handle that one. It has a random number generator if ever you need one. So it can generate a random number for testing purposes. What else? I think that's about it. So that's for NumPy. Next is SciPy. This is short for Scientific Python. And SciPy is an extension of NumPy. So basically it works on top of NumPy. Um, so anything in NumPy, it can work in SciPy as well. Um, so if you were to ask for features, it would be like um, there's interpolation for SciPy, so that means if you have two values, right, and you don't know the value in the middle, um, that's what interpolation will do. So if you were to like, where is that applied? Where is interpolation applied? So it kind of guesses for you what's in the middle. So an application of this one is in animation. You have two pictures, for example, and then you don't have the frame in between. So if you leave that to the tool to decide for you what should be in the middle of that, um, there might be a chance that it will get the correct data, or it can generate something random and incorrect data. So Um, either way, it can speed up the process a little bit if you automate it, but you're gonna have to risk a little bit that it's gonna look bad. Um, Other than that, sci-fi is also used a lot in image and signal processing, so there's a lot of that here in sci-fi. What else? So I think that's it for SciPy. Pandas, of course, this is the one that we're going to be learning today. So this is built on top of NumPy as well. It provides a lot of easy to use data structures like data frame and series. So data frame, you just think of um, Excel and Google Sheet, and that's basically what the data frame is. So how to like the rows and columns. That's basically what data frame is. It simplifies a lot of the data manipulation process. So that's why it makes it very popular library. Um, that's one of the main features actually. So yeah, more on data frames and series later on. What else? Another thing about pandas is that it's also great for like handling missing data, removing missing data, removing duplicates, uh, trans transforming data into something else. So yeah, that's what pandas are used for as well. Scikit-learn. Um, this is used a lot in both in the academe and the industry. So basically just for making machine learning models. All right. So it's well documented. It's a lot more user friendly than others out there. And it's usually the first choice that everyone goes to when it comes to machine learning. Um, Features. So in terms of machine learning, it has both supervised and unsupervised learning. So we'll be learning on that later on. Um, we also have model evaluation. They call it model evaluation. So you are trying to gauge how good the performance is of your model. So it provides uh, features for that as well. Next is matplotlib. Now, matplotlib is by itself, um, can work by itself. So it's really flexible, it's extensible, it has a lot of tools for different kinds of plots, really. But from what I've learned, the learning curve for matplotlib is actually quite high. So in terms of learning matplotlib versus other libraries, most will find it a bit harder to learn matplotlib. Um, so that's why we have something like Seaborn or Pygel. It makes it a lot easier for us to make those kinds of graphs when we have our results. All right. So again, here Seaborn is based on Matplotlib. It works on top of Matplotlib. Um, so basically, you can just pass Seaborn directly to Matplotlib and then create the plots there. Um, what else? It has features that Matplotlib doesn't have, like built-in themes and color palettes. It has data aggregation. So like, um, if you want data instead of being separated into um, different columns, it would end up as one column instead, and then you'll just have one piece of data. So this is really good for comparison purposes. If you were to use comparison charts, like other comparison charts, like count charts, yeah, if I remember correctly. So those kinds of things. All right. We don't actually need this one. And this one as well. Okay, so we actually have a kind of tutorial notebook. So you just need to click on this one and then it will take you to something like this. So this is Google Colab. This is an online version. You can just think of this one as an online version of Jupyter Notebook. But it's owned by Google, of course. It's connected to a computer on a cloud, so you're gonna have to expect that this is a bit slower compared to if you have it in your device. So it's gonna be faster if you have it on your device. And then, uh, yeah, there are some additional lessons here that you can refer to if you ever get lost. So yeah, just bookmark this link and use this as your extra reference for pandas. All right. Not really what we need. Okay. So loading the Python libraries. We're gonna input these things. So numpy as np, sp, pandas as pd, mpl, and sns. All right. So we're gonna start here. Uh, sorry. So I'm gonna say import and then okay, import numpy as np, import import scipy as sp. We also have import pandas as PD. Um, hmm, okay, so we're done adding those import codes. Next is this is how to read data using pandas. Um, we have a pd.read CSV. So if your data set is saved as a CSV, then you're gonna have to use this method. Um, if it's an Excel file, then you're gonna have to use read Excel. If it's a DTA, SAS, or HTF, then it has its corresponding methods. So DTA is not really that common for us, right? Um, DTA is actually a Strada data file. So this comes from specific software, basically. The SAS 7B that stands for Statistical Analysis System. So it's a different kind of software as well. H5 is hierarchical data format. Um, and mm, it also comes from other software. So it really depends on where you get your data. Okay. Um, let's see. We should have in the LMS. Oh no, wait, we don't have it there. Let me see if we have a data set available. I think we can just get one from the previous batches. I don't actually have it here with me. Um, let's try this one. It must be here somewhere. Data set. All right. Let's see. Stop. Excuse So, okay. So we have two data set here that I'm gonna download. I'm gonna share this one later on your uh in your batch. So currently this is the overall. I'll put it here in your batch later. So yeah, this is the basic syntax for read CSV. And it has a note here. The document has many option arguments to fine-tune the data import process. So basically more um, parameters that you can indicate to, like if your CSV has a lot of sheets, you can specify which sheet you want to open. Okay? Those kinds of things. Right. So let's try and open up a file. Okay. And then where is this located? So I'm gonna have to like go up. I'm gonna have to move these two. Let's see. Move. Right click. Duplicate, download. Where's the move? Move. Why can't I move it? Cut. Cut. And then paste. Right. So that it'll be a lot easier for us to access it. All right, so we're gonna say df. We're just gonna say df, short for data frame. But again, it's just a variable name. You can name it whenever you want. We're going to be using pandas, so pd dot read underscore CSV, because salaries is a CSV. And then we're going to say salaries, um, data set dot CSV. And then if we were to print df here, let's see if it will print out. Or maybe there will be an error. Okay, so as you can see, this is what it looks like inside of the salaries dataset. So we have rank, discipline, PhD, service. We have the gender and the salary as well. So from rows 0 up to 77. It's just showing us the first five and the last five. Okay, right. Um, for the other methods, it's just the same. It really just depends on what data type you have. So usually it's in one of these five, or if not, then you're gonna have to open it in a different way and then save it as a CSV or something. Okay, so exploring data frames. So this is one of the very useful um, methods that we can have. So the moment that a data frame is created, right? So if you're reading a resource, it automatically becomes a data frame. So with that, you have access to the methods and properties for the data frame, right? And one of those is actually the head. So df.head is actually quite simple. If you run this code, it will show you the first five um, rows of data. So this is useful for just checking something out um, with your data set. Okay. Next is what comes next after that. All right, so we'll have some kind of exercises. Can you guess how to be? All right. So if I were to ask you, RJ, um, how would you write the code out to read the first 10, 20, and 50 records? Do you have an idea? You can use Google if you want.
Okay, sir, wait po.
So researching is also a skill. If you know how to research, how to look for the answers, the solutions, and then try them out. If it works on your end, then that can be considered as a skill as well. It's not like you're looking for answers for an exam. You're looking for answers for a specific process. So there's something different about that. All right. So if you're just using a regular DF head, that gives you the first five. So what if you want the first 10, 20, and 50? How would you do it?
So, nakita ko po, ginamit po nila yung DF10, 20, at saka 50.
Mm, okay. Can you read it? The exact code?
So, ganito po yung nakalagay. In-import niya po na yung pandas as PD.
Mm-hmm.
Tapos df underscore 10 equals to pd.read CSV. Tapos yung file po ng CSV.
Mm-hmm.
Tapos n rows equals to 10. Tapos print first 10 rows.
Uh-huh.
Yun po dun sa first 10 po. Tapos yung sa 20, ganun din po. Pero iniba niya lang po yung sa n rows. In-equal niya lang po sa 20. Tapos print niya po first 20 rows. Tapos comma df ng 20. df20. Wait sir, i-ano ko.
All right. Let me enable the share. Uh, all participants. Yeah. Okay. You can go ahead and share your screen.
Ay, sinend ko po sa ano sir.
As a chat. Okay.
Apa. Ganyan po yung lumabas.
You have 20 N rows. All right. So you were using the parameters for reading. All right. I'll accept this solution. This is also correct.
Tapos
Uh,
meron din po isa pa ganito.
okay. First and last. Okay. So this is a bit more roundabout.
Opo.
So yeah, if this is what you want to try and avoid because you're not using the library correctly.
Yun nga
So
lang po.
yeah, in this case, this is how you should do it. So it's actually quite simple. So if df head returns the first five, what you usually do next is if you've learned something new, like a new function, a new method, what you should usually do is look for that method. So like say dot head method in data frames. Okay, so you have to indicate the object that the method is working on to get the correct um reference because it can be that a different kind of object, not a data frame, has the same method name called head, but they have different results. Okay, so you have to be careful with that one. The head
Eto
method.
sir, may nakita ko parang ganyan po. DF head yung ginamit niya.
Mm. Yeah, so that can be considered correct. So it's using the F head and then the number of rows. So that's
Rows.
exactly the
Okay.
one that I'm looking for. So here, this is what the AI suggested, but it's not really the one that I'm looking for. What you should be looking for is the syntax and the different parameters. So for example, here, pandas data frame head method. Um, if not specified. So that means this is the syntax data frame dot head and data frame here is whatever variable you store the data frame in. Optional, the number of rows to return to default is 5. So meaning this is how you should do it using the pandas library. So you could just say df dot head of 10 df dot head of 20 and then df dot head of 50. Um, let's take a look at just 50 um, so that it will fill out the thing. So 50, so as you can see, it's showing us all of it, starting from zero, index zero up until where's that? 49. So these are the first 50 records for this data set. All right, you understand?
Yes sir.
All right. The next question is, can you guess how to view the last few records? So if we have head, what do you think should we do to have the to view the last part?
Maglalagay ng negative sir.
Negative. So let's try that out. So if you were
Sa huli
to
mauuna.
Yeah. So if you were to was sort of the last few records, so it doesn't really indicate what, right? So if we say -5 and then compare it to um yeah, let's just use -5 for now. It doesn't seem to work. Where's it? It doesn't seem to work. How many items are there? Nope.
Ano pala sir? Gagamit daw ng tail?
Okay, so there are 77, 78 rows overall. So take a look at the hint. Oh no, wait, that's not loading.
Ganito, sir.
Let me see.
Yung last three records, kunwari po, gusto nyong ma-access or makita.
DF tail. All right, let's try it out if it's correct. So you should be able to view the same five records. So these are their, I guess I'll just take note of their service. So 10, 6, 17, 14, 15. 10, 6, 17, 14, 15. So if you were to say df dot tail and 5 run 10, 6, and 14, yes. So that's a good answer, RJ. All right. Data frame, data types. So data frame, remember, is just a data structure. It's a collection of data. And these are the different data types for the data frame, right? So we have an object. Um, the native Python type is a string, and then the most general D type will be assigned to a column if column has mixed types, all right? Um, it will be assigned int if um, if it takes it as a number, it's usually it. And float if it has values that are very small, less than one, basically. So anything with decimal, that's what a float is. All right. So that's for data frames. Okay. Um, hmm. So if you want to check a particular column type, this is what you need to do. You need to access the uh, column and then write out the type as the property. Okay. So if we try this one out here, we have PHP. We'll use PHP. So df dot. Oh wait, it's not that. Subscript operator, right? Uh, PHP and then the D type, right? Series object has no type. D type, D type, D type. All right. So as you can see, it's the D type of 64 for PhD. So, you can guess the data set or not really guess. If you just want a reference to what the data set was, you can just use this code and then look for the D type property, right? So these are the different attributes for a data frame. So we have the types, the one that we tested earlier. We have columns. It will show the different column names. We have axis. So this will list out the row labels and the column names. We have endim, or the number of dimensions. We also have the sizing, which is the number of elements. And then finally, shape, return a tuple representing the dimensionality. And number 10, numpy representation of the data. Okay, so these are the basic data frame attributes. You can use this to um, okay. I think we're good here. Let's just proceed to the next slide. All right, another exercise. That's cool. Um, so if I were to ask you, RJ, find how many records on this data frame has. How many records? Hello, RJ.
Hello, sir. Ayun. Lolo ko po kasi yung mic. Sorry po.
That's okay.
Wait, sir. Yung PD.data frame, sir. No?
Um, PD.data frame?
Yung po
No,
yung
we're
lumalabas.
we're
Wait.
using df as the variable. So PD dot um we're using
Def
PD.
data. Ah, okay. Ganito kasi yung lumalabas sa akin, sir. Wait lang.
Let me see.
Tapos inaano niya yung length ng df.index.
Let's see. Uh,
Lendf.
so it created its own data frame and then len of index. So again, this is a roundabout solution, but it can still be considered correct. So the question is find how many records this data frame has. So if we actually return to the one before, right, what we're gonna see is list the row labels and column names. Hmm. Right, so how many records this data frame has? So I think we can do something like this already, just using the axis. All right. Range index. Stop range index 28. Step one. All right. So that's the answer for how many records this data frame has. So it basically shows you um, the question was how many records, right? Or in this case, how many rows?
Yes, sir.
Yeah. What else? So on to the next one. If you were to be asked how many elements are there, how would you answer it? Okay. Hello, Bridget?
Hello, sir. Wait lang, sir. DF size. DF sizer.
Yes,
Sizer.
that's correct.
Size. Sorry po.
That's correct. So it's actually size. So if you were to put that one here and then say df size, so it's gonna say 468. So if you remember, there were uh 78 rows and then six columns, right? So
Yes,
if
sir.
you were to multiply that one, that's 468. But instead of multiplying it, right? Because you don't want to like open the data set and then just
Count.
do it manually. So what they did
Yes.
is they provide a property, and that's actually the size property. Okay. What about this one? This is rather easy. What are the column names? How would you display that one?
DF dot columns, sir.
Yep. It's pretty straightforward, right? Like the way
Yes.
they name the functions. So rank, discipline, PhD, service, gender. Okay. And last but not the least, what types of columns do we have in this data frame? What types of column? So the data type, that's what it's trying to look for.
D types.
D types, yes, that's correct. So you're gonna say df dot d types, right? And that's what you will get. Okay. So you have object in64, object in64. So rank and discipline. Why are they not? Um, well, that's fine. Yes. Let's see. On to the next part. I think that's it. So these are the um attributes for. Let's see. Um, so we already know the head. We have the scribe here. So generate descriptive statistics so for numeric use only. We have the max and the min methods. So obviously it will return the maximum and the minimum. We have the mean, the median, of course, the STD, or the standard deviation, the sample, and the program. Hmm. Where's my PowerPoint? Where's I? That's the main, right? So the main median and the star deviation is also available for data frames. We have a sample. So basically it will return you a certain number of data set using the n here, just like with what we did with head. And then drop NA will drop all the records with missing values. Okay. So it's again pretty straightforward, head, tail, scribe, max, min. I think the confusing part would be standard deviation and then sample because you don't have the like Mhm. let's just go directly to the next one. So after this is an exercise ability. So that's okay. We'll just solve it one by one. Um so RJ, give the summary for the numeric columns in the dataset. So this one, if you were to give a summary, how would you do it? I don't think it's here. You're gonna have to search this one in Google. I don't think the answer is there. Hello, RJ.
Eto sir, may
All right.
nakita po ako. Gumamit po siya ng ano, df.describe.
Mm,
Sa
describe.
function nito.
Let's try.
Yung method daw po na yun, nagpo-provide ng descriptive statistic for numeric columns, including count, mean. Okay. Lahat na.
Yep. So as you can see, it already provides everything that is needed. So count,
Opo.
mean, standard, min,
Max.
20%, 50%, 70% of all the numeric columns. So just with this function alone, it saves you a whole lot of time
Yes, sir.
and effort, right? Okay. What are the mean values of the first 50 records in the dataset?
Yun na yung mean, sir, ata kanina.
Yeah.
Hmm. So, gumamit po siya ng df.head tapos 50, yung 50, first 50 records. Tapos, sinundan niya po ng dot min. Parang ganito siya.
So
Kaso 5 lang pala nakalagay. Ayun, sir.
let me see, let me see. So you're actually almost there. Basically, instead of five, you could have just put 50 there, and then
Yes, sir.
automatically those are the um mean for that question, right? Okay. Let's see. Let's have our second break first, RJ, if that's
Yes,
okay.
sir.
Just a quick break, 10 minutes. Uh, I'm out of water and my voice is very hoarse. All
Okay,
right,
sir.
just 10 minutes.
Okay, sir.
All right. RJ, are you still there?
Yes, sir. Yes, sir.
Mm, yeah, DF head and then dot mean. You could have just directly dot head and then dot mean directly, but this is fine as well. All right. So, when it comes to selecting columns, it's just as easy as doing it like this. So, the same as how we select keys in a dictionary, it's also how we select columns in a data frame. So, it needs to be in a subscript operator like this one. And then if you want to use the column name as an attribute, then this is the method that you want to use, right? The dot method. So there's a note here. There's an attribute named rank for pandas in data frame. So to select a column with the name rank, you should use method one. So just in those rare cases where um, an attribute and a name for a column are actually the same. So usually method one is the safer choice. Just so that you can be sure that you selected the correct one, rather than this one. Okay. All right. These are more exercises. So calculate the basic statistics for a salary column. All right. So basic statistics, whenever you hear that one, we're just gonna show the same thing as described here, but what we want to see is for the salary. So what should we do? We have to what? Since it only wants the salary column, we have to select it first. So DF salary, all right, and then so
Describe
we
na lang,
have,
sir.
yeah, that's correct. That's correct. And automatically we get this one. Okay. Um, so it's all float data type. Okay, just so to show accuracy. For the other questions, find how many values in the salary column. So we're just basically counting, right? So instead of describe, what we're gonna use is the method called count, right? And then it will show you how many there are. So 78. It's the same number as how many rows, right? But in certain cases, there are data sets where there are combinations of letters and numbers. So you might be looking for, let's say, the entries where there are letters correspond to another part of the project, and what you're looking for are just the ones with um, numbers in them. So that's where count can come in quite handy, basically. And last but not the least, calculate the average salary. So average, what's another word for average? RJ?
Hello, sir. Yun po.
What's another word for average?
Naiinis na ako sa ano.
Are you okay?
Average po.
Yeah, what's another word for average?
Mean po.
Mean. All right, that's correct. So if you're just looking for the average, then just get the mean.
Sir, hindi ba nagkakrak-krak yung boses ko?
Sometimes.
Sorry, sir.
That's okay. I'm also having a hard time because of a cough. All right. Data frames, the group by method. So the group by is actually very, very handy. Like if you want to split the data into groups based on some criteria, if you want to calculate statistics, or simply to use this function, whatever function this is, in R. So you're not using Python, you're using the R programming language, I think. I think that's what the R means. Um, so let's expand on this a little bit. So if you want to use the group by, let's see. Um, so for the group by method, basically just imagine a rows, right? You have rows of data that you want, and you want them to be grouped together based on the values what they have in a specific column. So let's say you want to group all the rows where the age is greater than 18, or you want to group all the rows where the age or where the gender is male or female, that kind of thing. So it might seem that it's not that important, but it's actually very, very useful because you're filtering in two ways. You're filtering by column and then by rows, and that's a very powerful method, actually. The group by method doesn't work by itself. You're gonna have to use other functions on it to be useful. Uh, Maybe some aggregation functions, just so that you can make the most out of it. All right. So if we say, in this case, it's using rank, right? So that's why we're going to be using the subscript operator to access that column. Okay. So if we say group data using rank, so they have rank, they have that group by and rank. So this is what it will look like afterwards. Okay, so if you remember, this is what the F will look like. Okay, we have rank. All right. Now you want to group by all the columns according to the values on rank. Now, what do we have here on rank? We have prof, associate prof, prof, and then I don't know what else is in there, but we can just use the group by method for this. So if we say df rank is equals to df dot group by, what's that? Oh, yeah, rank. And then rank. And then all we have to do is view what df rank looks like. Okay. Hmm. Oh yeah. So this is the part where I said that it doesn't really work by itself. So when you group it by rank, you should be able to view it, but um, you can put it this way. To Python, Python is confused, right? You are instructing Python to group the data into according by rank. Combine all the rows according to rank, right? That's what the definition is, right? If you go back, this one, let's see, groups based on some criteria. So it's grouping all the rows that have the same data. But to Python, what does it do after grouping all that data? So that's why it just says here object. It saved it as an object, but it doesn't know what to do with it. So if you were to put something like a mean method here, so what do you do with the data after combining? You get what? Or how would you combine the data? So you're looking for the mean, for example. And in this case, it's not showing up. There's an error. What a very long error. So what is happening here? Let's see. Maybe it doesn't work if I do that directly. Um, dot me. Nope. Aggregate function failed. How me the type object? Type error could not convert. What's this? There seems to be data that's wrong. We need to open the file. Where is it? We need to open this one. Salaries open. I think I edited this file as an example before. So maybe there are some data sets, data that's not correct. Let's see. Uh, is it located again?
Yung sa discipline ata, sir, na ano,
Pa. It's been,
10,
uh,
sir, sa discipline.
okay. So we have rank. So assistant prof. So why does it say cannot convert to numeric? PhD says, huh. All right, so we're gonna have to. What should we do? What should we do?
Pwede ba yun, sir, gamitin yung function na count?
Wait, because in our example here, um, we have for each numeric column for each group, right?
Opo.
All right, so I got it. So we have to specify to the mean that it will only select the columns that are numeric. So there's a parameter for this, so it's numeric only, and you should
Mm,
set this one to true. So with this, it will only select the columns that are in numbers. So if we try this one out, there we go.
yun.
So now we have uh, the mean for the associate prof and PhD. So you understand what we're trying to do. Um, we're trying to get like what does Python do after combining all that data? So that's why group by doesn't work by itself. You have to tell it what to do afterwards with that data. Like, do you want me to sum it all up or to just get the mean like this one? So I don't know if you use Power BI. Have you ever used Power BI?
Hindi pa, sir.
All right. So if you're familiar with Power BI, you'll see this as something familiar because there are um, features there that you can do something like this with your data, but it's usually a lot slower compared to this one using pandas. So yeah. So right now it might not mean much, but it's actually very powerful to do something like this. Especially because you can tell Python which column you want it to be grouped by. So it really saves you a lot of time. All right. Next is once group is created, we can calculate the various statistics for each group. So you have rank, and then basically it's just choosing the salary and then getting the mean. So it's the same thing, choosing the rank after grouping it by rank, you are selecting the salary column and then getting the mean. It's basically the same thing. So there's no more need for the numeric only because we know that the salary is uh, a number, that number data type. Okay. So group by performance notes. So no grouping or splitting occurs until it's needed. Creating the group by object only verifies that you have passed a valid mapping. By default, group keys are sorted during the group by operation. So you may want to pass sort false for potential speed up. Yes, so this is just for performance notes. If the sortation isn't actually useful, you can put this one there and then it will make it faster. Not that fast, but there will be at least a difference, especially if your data set is in the numbers of thousands, right? So, uh, yeah. Um, what else? So we can't really show that one for now because we don't have a data set that's really large. Oh wait, I think we do have one. That's for the light data set. So as you can see, it's 9.5 MB. This is actually pretty big for just a CSV file. So there's a lot of rows there. But yeah, we'll get to that. Oh no, wait, we can't actually. Yeah, there won't be enough time, but that's okay. Data frame filtering. So to subset the data, we can apply Boolean indexing. So we can apply it again here. Basically, this is just used as a filter, right? So how do you filter the data that you want? So basically, you're creating a new data frame here using um using only the rows where the salary is greater than 12,000. So in this case, that's how it did it. Um, any Boolean operator, yes, of course, can be used. If you're looking for specific genders, for example, then it has to be in a string format, of course. All right. So let's see. So please remember the syntax for doing something like this in filtering. You have to declare the data frame first, and then you are selecting a subset of data frame where that column's value is greater than 12,000. So it might seem confusing, but it's basically the same as you doing a subscript operator. Okay, but you know you're just selecting the column with this specific condition. So if you try to follow the example that it had df sub df with uh what's that again, salary and then greater than 12,000 and then box, and then we have to take a look at the sub. Yeah. Mm. It's not filtering properly. Why? DF sub DF and then DF salary is greater than or equal to 12,000. But why do I see? Ah, okay, it's 93. All right, all right. What if I were to say? Am I missing a zero? Is it 100? Okay, it's 120,000. That's why. All right. So here are the rows where um the value for salary is greater than 12,000. Right. By the way, remember that if you're manipulating a data frame like this one, the resulting uh value is still a data frame. So you have to remember what object we're currently working on, okay, in order for you to not get lost, right?
Sir,
Yes,
I have a question po. Pwede
yes.
po ba sa isang line, kunyari yung DF sub na yan, pwedeng dalawang filtering yung gagawin? Kunwari po yung greater than 120K na salary, tsaka female, or need pa po ng isang line?
So two conditions. Let's see. So if we were to use something like this one, EF, and then gender, no wait, sex, um, is equal to male, for example. Is this correct? Uh, hmm, yes, invalid syntax. I guess what you can do if it doesn't accept something like this, what you can do is create another data frame. So df sex, for example, df, and then you're gonna be using um df sub this time. Wait, wait, wait. You're gonna be using df sub instead of the regular df, and then df sub uh sex is equals to male, for example, and then let's just print this one out. Right. So in this way, you'll have to filter it out one by one. Uh, let's see if we have an example here that we can filter out. Yeah, sequence. No, I don't think we have. So you're gonna have to do it one by one.
Okay,
Um,
sir.
this
Thank you po.
is yeah. All right. Um, Data frames slicing. So there are a number of ways to subset the data frame. So either you create a new data frame out of the columns, you create a new data frame out of some rows, or the combination of rows and columns. So it really depends on what data that you need. All right. So they can be selected by their position or their label. Either one will work. So this is just very basic, selecting the salary. If you want to select two or more columns, then you're gonna have to put it in a bracket, okay, in a list type. So if you want to select two or more columns, if you want to select rows and by their position, then you're gonna have to do something like this. So kind of like what we do with list, really. It's really just similar. Um, it also has the index of zero, so the last value will be omitted, right? So in this example, if it's 0 to 10, then what you'll get is from 0 to 9, all right? So the method lock. So if you need to select a range of rows using their labels, we can use the lock method. So in this way, for example, the f sub location, you have to first indicate the rows. And then after that, you can select the columns that you want to display in your output. So rows first, and then the columns that you want to display. So if you have to be specific. But yeah, if you need to select a range of rows and columns, use their bosses to reduce the positions. We can use the iLock method. So in this case, we're using the positions of those columns. Okay, so from the leftmost, it will start at 0, and then it will go up by 1 as you go to the right. Okay, so that's why we have services, year, sex, and salary. Um, so nothing too difficult so far. What you need to actually do with this is to be familiar. You don't need a very complicated exercise for this. Just be familiar with what are the basic um, functions and methods and the syntax that they need in order for it to work, really. So, from my experience, the lock and the I lock are methods that are used a lot because you have to select very specific rows at any point. So what we do is we usually remove um, the NAs first and then the blanks. And then after that, what you're left with are the clean data. Next is you're going to remove the data that you don't need, like the specific rows that you don't need. So you'll get a fewer data, but uh, you'll be left with what you need, really. All right, so here is a summary, if ever you want a summary. So if it's just the 0, then it's the first row of data. If I, then it will be the I plus nth row, or I plus 1 row. And a negative 1, it will be accessing the last, all right? Um, if you were to put just a regular column, that means it will select all the rows, okay? If you put 0, it means select the first column. If it's negative 1, the last column, right? If you want to select the second column, then you'll just each column from the left, you'll just add 1 to it. So you have to count it manually. Um, 0 to 7, since this is the first um, argument, then it's for the rows. The second argument is always for the columns. So in this case, in this example, you are selecting all the rows, but only for the first two columns. So the 0 to 2. Yeah, because 2 is not included. Um, Here, second to third and first two columns. So second to two, second to third rows, and the first two columns. So you might be confused. For the rows, the last number is included. For the columns, the last number is not included. See? So it needs some getting used, to, really. But anyway, you can see it visually afterwards, and you can make the edit. It's not really that critical that for you to remember. Um, what's important is the syntax, right? And last but not the least, you have specific positions. So you have the first, the sixth rows, and then the second and the fourth rows. So this is very, very specific. And it's not very that common. Usually what you're looking for is the whole, the set as a whole, and then get the result from that instead of looking at things individually like this one. The only case where you are looking at this individually is because instead of analyzing what's like the mean or common between all of the data, you're looking for the outliers or what makes the things that are not in range different. So these might be the ones that are making great improvements, and you want to see what makes them different than the regular ones. Okay. It really depends on the data that you have. So in some data, you're looking for the outliers or the ones that are not in the mean, not in the median range. You're looking for the ones that are outside of the range. Um, so yeah. And with that, I think I'll have to stop here for today. It's already 5. So I'll just endorse to Ma'am Shai that we ended up at sorting. So she'll have to continue starting from here. Okay.
Okay, sir.
RJ, yeah, do you have any questions?
No naman, sir.
All
Okay
right.
naman po lahat.
All right. So just make sure to practice. All
Yes,
right.
sir. Yes.
It's such a waste if you don't practice this one, you're just gonna forget it. It's like a muscle, right? Your brain is like a muscle
Yeah.
you have to train with. All right. So if you have no questions, have a great weekend, and I hope
Sir.
I'll see you in a different course next time. Right.
Yes, sir. Yes.
Goodbye.
Thank you, sir.